Okay, next step. Often one of the first actual commands or settings you should do to start a drawing is what's called units. UNITS. Just type it in, hit enter, and you get this window here. Now, this is why I labeled this file, this template file, as decimal, is because right here we're going to look at length, angle, direction, precision. Pretty much that's about it. And right here, the length. Basically, I have the options: architectural, decimal, engineering, fractional, scientific. Architectural, if you ever need to or want to do one, this is set up in feet and inches. Decimal is simply decimal. It's not necessarily tied to any units in general. However, I'll tell you now, decimal 1 is 1 inch. It just happens to be. Not because of here, the insertion scale, but that's just the way it is. Architectural, decimal, engineering, usually, normally feet, decimal feet. Fractional is just that. Instead of seeing information in decimal form, you're going to see it in fractional form. And then, of course, scientific. Now, fractional I don't recommend using. Scientific is usually your scientific notation, something times 10 to an exponential. So in this case, we're going to leave it at decimal. This here, precision, my recommendation, again, it's just my preference, my recommendation. Your boss, you'd come up with your own preference. Your boss, your company, someone will probably assign or say, here is what we're going to do it to. They will set the standard unless they just leave it up to you. So here, 0 is no decimal point at all. 0.0, 2 decimal places, 3 decimal places, 4. I recommend going to 4 decimal places. Many times, whether it's machining or even not, just general work, whether it be woodworking, whatever it may be, a lot of times you can go down to a 1/16 of an inch, an eighth of an inch, eighth of an inch being 3 decimal places, 0.125. 1/16 is half that, 0.0625, 4 decimal places. And then, of course, for manufacturing, precision machine, you got tenths, hundredths. I've got a th at the end there for if I'm not being clear. Thousandths, and then 10 thousandths. So a lot of times machining, that is some of the accuracy they'll get to is thousandths or 10 thousandths of an inch. Very, very, very small. So this is my recommendation. Now, this here, this information, this precision is only going to show up at certain locations, and I'll explain that in a minute. But angle next is angle. Angle, go ahead and just leave it at decimal degrees, but go ahead and drop down and look. You got decimal degrees. You have degrees, minutes, and seconds. Minutes is 1/60th. It's a degree divided into 60 equal parts. Seconds, just like time, is a minute divided into 60 equal parts, each of which being a second. So degrees, minutes, seconds. Here's also surveyor's units. Surveyor's units uses degrees, minutes, and seconds often, but they also refer to north, south, east, west, and so on. If you've ever seen a plat, boundary survey, anything like that, you'll see north, so many degrees, minutes, seconds, east or west, south, so many degrees, minutes, seconds, east or west. Then you have your gradients and your radians, and we're not going to get into that. So I definitely want to leave it at decimal degrees. Again, precision. Now, right now, it says 0. And previously in class, as well as other videos, I've commented that unless you type in the length and or the angle, even though your dynamic display shows that that's what it is, that's not absolutely true. These numbers will be rounded. You want to get a little more accurate, then go down to whatever this is, 8 decimal places, I believe. It's still rounded unless you type it in yourself. So same thing here. You think you're drawing a line at a specific angle. Well, it's being rounded unless you type it in. So my recommendation, go ahead and go 3 or 4 decimal places as well. You can always change this whenever you want, but until then, I like to see, I like things to be a little bit more precise if at all possible. So seeing something that is 90 degrees, I want to make sure at least to 4 decimal places, 10 thousandths of a degree, that is the case. So again, decimal, 4 decimal places, decimal degrees, 4 decimal places. Right here, clockwise. If I click this, it will make positive angular rotation in the clockwise direction. It is not checked. I'm going to leave it not checked or unchecked, which means counterclockwise is positive angular rotation. That is pretty much a standard, a norm, very, very common setting to be left that way. So I'm going to leave it that way. I'm not going to change up too much. I don't want to get into other habits than what's commonly used out there. Leave insertion scale alone. It's at inches, no big deal. Lighting, we're not going to bother with that. Later on, you get much more advanced and you get into solids and surfacing, then that might help you. Before hitting OK, right here, direction, dot, dot, dot. Go ahead and click there. And I see I have a new box, a new window, base angle, east, north, south, west, south, other, and then these degrees here. Well, I've always told you, base or the base angle 0 degrees is horizontal to the right, and that's where east at 0 degrees is. Don't mess with changing these. If anything, their north would become, if you change it, north would be your 0 degrees, west. So leave it at east, please. Again, horizontal to the right is 0 degrees. That's our base where we start from. So leave this alone. I just wanted you to see it so that you'd know if need be it could be changed, or if something's going wrong you'd want to check this. So hit OK, and again, let's see, decimal, 4 decimal places, decimal degrees, 4 decimal places. This is not checked and direction is still at east, so I'll hit OK here. For units, I'm going to call it a quits here. That's 7 minutes, and we'll move on to the next one.